We're making a ransom note. It's harmless, but still a ransom note. You're gonna think, wow, you're gonna like this algorithm. It's pretty cool. So let's get started, all right? So what I did was I grabbed some text from the web and created a ransom note here. And we're gonna see by creating a function if we could loop through this, all these words here and see if it's possible to make a ransom note from it. Or in this case, to see if this ransom note is valid and can be made from this text here. So what we're going to do is create the function harmless ransom note. And we're going to give it two parameters. One is the note and one is the magazine note. And I always like to invoke the function because I forget. And I'm wondering why something doesn't work. So the two arguments we're going to pass in when we call this function is the ransom note and the magazine note. There it is. Okay. So right off the bat, we want to create a hash table to keep track of all these words and put them in a table. And we have to deal with things like punctuation. We have to deal with things like capitals. And so here we go. So we're going to take those things away for both the note and the mag note. So we're going to say a note array equals note dot to lowercase dot split. So lowercase makes the string all lowercase, and split turns the string into an array. And we're going to split it at every space. Same thing with the magazine note. Mag array mag note dot to lowercase dot split. And we'll split it at each space. So let's have a look and see what that looks like. I'll just do one so you'll see. See? It took all the words here and it just split it at each space. And it made, the D, Durant here, lowercase. So it does the same thing for the magazine array. And now we're going to have a scrubber to deal with the punctuation. So we'll do the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Well, that was a lot. And split. So we're not going to split at the space, we're going to split at each word. So each word is going to be its own character. So I'll show you what that looks like. And run. See, it's a unique element in the array. So now we're going to create our table, and we'll just call it magobj, and it's an empty object, and we're going to create our hash table now. And to do that, we're going to do mag array, right? For each word. Okay, and we're going to create an entry in our table to keep track of. So we're going to say if magobj at the word, if the current word that we're iterating over is not a property in the mag object, make it a property. At the word, and we're going to set it to 0. No matter what, we're then going to increment it by 1. So if it's a new property, set it to 0 and increment by 1. Or if it's already a property, increment it, one time. And you gotta watch spelling here, magobj. Okay. And so let's return the magobj. take a look at what that looks like. Okay, so you see we're keeping track. We have this, for instance. This appears twice, so it's keeping a record of the amount of thises. So we can use 2 thises in our ransom note, essentially. We have a few ises. We've got 1, 2, 3 ises, right? So that looks good. We can create a ransom note with a maximum of 3 ises. Okay, so the next thing is, we don't need to return this now. The next thing is we're going to do our note array. And we're going to loop through the note array, and we're going to see if, compare it to the hash table, and see if we could pull words from there to create our ransom note. But we're kind of doing it a little different. We already have the ransom note created. We're just looking to see if it's possible to make one. And for that reason, it's easier to use a state variable to keep track whether or not it's possible. So we'll set up a Boolean here. Note is possible equals true to start with. And we're going to say note array dot for each. Okay. For each word in the note array. Okay. And so with this little do-gooder, I sound like Bob Ross, we're going to kind of like scrub through the words of our alphabet and see if these letters are possible, because we have to deal with the punctuation, right? So let's loop through each word and look at each character. For I equals 0, I is less than word.length, I plus plus. Increment by 1 each time. For each, so each word we're going to look at each letter in the word, right? So we're going to say current letter, which is word at I, position I. Okay. So we want to set up a string here to kind of keep track of this. And so we're just going to say string equals is an empty string right now. And right now we're looping through each word, and each word we're looping through each character in the word. And we're going to say if alpha dot index of the current letter is greater than -1, meaning that a word is relevant and can be found in this alpha array, which is A, B, C, D, all the way up to Z, right? If it can be found, put it in the string. If it's a quote, like a punctuation, don't put it in the string. So string plus equals the current letter. Okay? And so when we're done with the word, we're going to do what? So we're going to take the string and we're going to make it available. Okay, well, for that reason, we might want to put that string up top. And now it's available. Right? But I think we could do it in here. Let's not get crazy. Keep it together. Okay, so now we got to set up some logic in this bad boy word. If right, okay, okay. So now we're gonna look at this thing. If magobj at the string is a property, we're gonna decrement magobj at the string by 1. So what this means is if the current, so we're looking at the word, right? We did this little evaluation. We still have the word, which is this string now. And we're looking at the object and we're saying if this string is a word in the mag object property, remove it from there. And we have to account for the fact that if mag obj at the string is less than 0, meaning we've decremented it once already, and then if it is 0, and that means that if we have to decrement it again, it'll be -1, and we would say that we don't have it, right? So notice possible equals false. Right? Else we have it. All right. Else note is possible equals false. And then return note is possible. Okay. We're saying here if this string, this word here, which we stripped of all the punctuation, is a property in this hash table, we're going to decrement the word, and then we're going to look at it, the possible use case of what if there are no more words. We're going to say note is possible. Otherwise, if it's not a property, note is possible equals false, return note is possible. But as you can see here from the hash table as it currently exists, we have a problem. We have punctuation here. We got to strip that out. So we've got to use this same logic here. This little doodad has to become available to this word scrubber. So before we do this logic, we've got to essentially put all this in here before we could do the evaluation, right? Because watch. So instead of putting the word in, we're going to use the string. Right, so basically we're going to look at the word, we're going to loop through the word and do this evaluation where we're going to look at the alphabet. We're going to see if there's an index in there, meaning that the current letter in this word exists. So if we're looking at the word the, we're going to look at T, we're going to look at H, we're going to look at I. And each time we're going to go to the alphabet and we're going to say, hey, alphabet, do you have a T there? And if it can find it, it's going to add it to the string. It's going to then look at the H. It's going to say, hey, do you have an H? And -1 means, no, I don't have an H. But we're saying if it's greater than -1, it means, yes, I have an H. All right, so add the letter to the string, and so on. And then we're going to say, once the string is completed, we're going to say if it's not a property in our table, make it a property. And if it exists again, because we're evaluating each word in our magazine note, we're going to reference the table and see if it's a property there, an existing property. Because if it is, we're going to increment it. Otherwise, we're going to just set it to 0. So just to kind of set that up for a moment so you could see, let's just console log out. Let's just return the mag object. Remember, we returned the mag object before we had our punctuation. Let's do it again. And we've got a problem. What is the problem? For let I. Okay, run it. Okay, good. See? No more punctuation, no capitals. Let's remove this. Okay, so we're doing the same stuff here, and then we're saying if the note object, right? We're saying the note array, each word in the note array, we're doing the stripping, we're moving the punctuation, and then we're going to our hash table and we're saying, hey, hash table, do you have the current word in our note array, our note, each word in do you have a property that's in there? It's in the hash table. If you do, decrement it by 1. And if I have, like, let's say 2 thes in my array, my note, ransom note, I can't speak today. If you have duplicates, like if you have like 2 thes here, check to see if there's another the that I could use. You know, like for like this and is, for instance, there's more than one, so I could use more than one. And so return false if you don't. And if you have a property with the current word, that's great, do these things, but if you don't, return false so that we know that the note is not possible. So let's run it. Okay, let's clear that out and run. True. Okay, so we know that Durant concerns players on the court. Durant concerns players on the court. So that's possible. All right. We know Brad is not in there, so we're going to run it and we should get false. Good. We know that I think we have only 1 on, so let's put 2 ons in there and see. We get false. Good. Let's run it. True. Do we have 2 thes? Let's see if we have 2 thes. Let's do this. We know we have 2 thises. This should be true. Good. But we don't have 3 thises, so this should be false. Good. So this is all working. Okay, so how do we make this a little sweeter? Well, we have duplicate logic here. This is something that we're using over here too. So let's create a scrubber function and just use it once. Or just, create the logic once. Scrub. Okay, so we're comparing the alphabet. So this is taking in a parameter of an array. Okay, and what else is the scrub doing? It's taking in an existing word. Right, because we're looping through this word here. So let's get that out of there. Put it in here. We're going to return the string. This is what we're going to get back once we run our function. And so this is going to just be R. Okay? So now we're going to go in here and we're going to say const string equals, right, scrub. It's going to take in alpha. It's going to take in word. See how we're saving a bunch of like code here? Let's do the same thing over here. Let's get this out. Okay, let's run it. True. Okay. Let's do two ONs. No, we don't have multiples of those. Let's put in a couple of thises. Okay, true. We have more than one this. Do we have three thises? No, probably not. False. And let's just put in my name. Run it. False. Good. Players on the court. True. Okay, so that's the harmless ransom note. I know it's a lot to take in, but it's a really awesome kind of algorithm to know. A lot of good stuff in here. And thanks for tuning in, and until next time.